Hi, I'm Shahan and I wanted to show you my evolutionary simulator. This is a project that I made in around 2 months in the spare time during one of my internships, and it's something that I wrote completely from scratch using C++ and WebAssembly. It doesn't use any sort of external libraries, not even something like PyTorch or TensorFlow. It's all written by me. I guess it uses kind of one library just for the UI, but nothing other than that. So what it does is it trains neural networks, kind of like this one that you're seeing down here live, to play games like Snake. But the interesting thing is it doesn't do it in like the normal machine learning way. It doesn't use any sort of back propagation. Instead, it does everything through this genetic algorithm, very much inspired by evolution. And you can see right now the AI is, pretty damn good at playing Snake. Probably better than me, to be honest. And this is actually, this version of the network you can see. And so on the left here, you can see the inputs. The inputs are just based on, where the position of the snake is and where the food is. And then these are the outputs over here. Based on what the network outputs, the snake moves around. So kind of to show you what's going on, I can actually scroll back through history and I can go back to generation 0 down here. So if I go to generation 0, you see the snake is really bad at playing because the network is just completely empty and it's all empty. But what happens is in each generation, there's 1,000 networks. And then what can happen is, the networks can have random mutations where a random mutation could be just like a random connection being added. And then over time, basically each network is evaluated. It's kind of like reinforcement learning. Each network is evaluated and actually plays the game. And based on that, I think it plays the game 5 times actually. And based on that, it gets a fitness score. And then based on that fitness score, it's kind of ranked. And then the networks that perform the best survive to the next generation or like produce offspring to the next generation. But the networks that don't perform well get died out. And the interesting thing is even something like the weights of the connections are also just decided randomly. So there can be a mutation where it like multiplies by 0.5 or it like, adds a certain constant, and everything is decided by evolution. Where it adds the connection, what the structure, the architecture of the network is, it's all decided by evolution. And sort of to go into a bit more detail, how it works is, the top networks are bred together in some sort of random algorithm. And the way the breeding works is kind of complicated, but kind of the TLDR is that the common nodes between two networks are always kept when two networks have an offspring. But then like the things that are not common are sometimes kept. And I can go into the details if you're interested, ask me more, but it's pretty cool. And you can see that over time it gets better and better, and it gets better at learning. And I can actually also show you, I can start a new training run completely from scratch. So if I go here, you can see a new training run completely from scratch, and you see how fast it's in the background right now. It's playing thousands of games, and there's actually 2 threads going on. There's one thread which does the machine learning kind of learning and evolution as fast as possible. But then the second thread is kind of the visualization thread, which when it kind of gets the state of the network and then visualizes it. And I use the 2 threads so that the UI doesn't really block the machine learning and the other way around. But I had to be very careful with kind of the locks for the network because it's the same network that's being kind of evaluated and also being visualized. So I had to make sure to be careful with the concurrency. And you can see, just within like 30 seconds of me talking, it's learned pretty good. So it's really cool that it's really fast. And one interesting thing also is there's this concept of species. So based on, kind of how similar a network is, you can compare two networks and get a number based on how similar they are. And if we group similar networks together in the same species. So you can see if I go in a later generation, there's a lot of different species. And then the reason that we do this is that, each network only competes within its own species mainly. It doesn't compete as much in the global pool. And the reason for doing this is it kind of allows unpopular ideas to kind of spread, meaning like sometimes there's an idea that's like not super mature, the fitness score is not super high, but like a lot of networks are kind of trying it out, and by not punishing those networks right away and kind of within one species, there is some sort of kind of headroom to experiment new ideas, because sometimes the best ideas end up working out over a long period of time. If we kill them right away, it wouldn't be good. So yeah, I had a lot of fun working on this project, and I hope it was interesting for you. And I also really wanted to mention that I didn't come up with all this from scratch. So this is based on a paper called NEAT, I did implement everything from scratch by just reading the paper, but like I didn't come up with all of the ideas. But actually, the paper doesn't really go into all the details of how they implemented it. So I actually came up with a lot of the ways that I did my implementation. So it's not exactly like one to one to the paper, but I was, really inspired by this paper, growing up when I first saw it. So I really wanted to implement it, and I did, and it's really cool. And also, it's implemented in kind of an abstract way. There's like an abstract class for game, and all it is you give it a network, and it has to give you like a fitness score based on that network, and then you can implement different games. So right now I just have Snake, and I also just have like an XOR for testing, but in theory I could add other games, and I want to experiment with adding other games sometime as well. So yeah, thanks for listening, and yeah, check out the code if you're interested, and yeah, bye.